Hello everyone. So today we're going to go over section 10.2, modeling and solving two-step equations of the form ax plus b equals c. So to begin, we will review the inverse operations of addition, which is to subtract. And the inverse operation of subtraction is then to add. For multiplication, the inverse operation is to divide. And finally, the inverse operation of division is to multiply. So as we talked about on the last day, we can use inverse operation to solve equations, looking at what is happening to the variable. So in the first case, example A here, we have x plus 2. So the inverse operation of adding 2 is to subtract 2. So we can do that to both sides. And we'll be left with x equals to negative 15. And likewise, we can look at x minus 7 equals to negative 3. So we can add 7 to both sides. And of course, we will have then x is equal to just 4. And the idea here is that the plus 2 and the negative 2 in the example A will eliminate each other, just as the minus 7 and plus 7 will do so in the second example. Let's continue. The inverse operation of negative 5 times x, that's what this actually means, is to divide by negative 5x as well. Sorry, negative 5. So we can do that to both sides of the equation. And we're left with x equals to negative 5. And finally, the inverse operation here is to be multiplying by 8 on both sides. That will eliminate the 8. Just as in the last example, the negative 5s will be eliminated. So we are, in example D, left with just x equals to negative 24. Okay, so the idea is if we have a two-step equation instead, then what we want to do is to isolate the term with the variable and then isolate the variable afterwards. Hence, it's two steps. Isolate the term with the variable and then you isolate the variable. To help us understand this, we can look at an example using balanced scales. Let's go ahead and do that. Okay, so 6n plus 6 is equal to 12. So we have n, 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 n. So 6 n's and then 6. So 6 ones. 1, 2, 3, 4, 5, and 6. On the right hand side, we will have 12 ones. And so what we can do in the first step of this question is to subtract 6 from both sides. You can see we want to remove 6 ones from both sides of the equation. So once you've done that, on the equation on the left-hand side, we have just the 6 n's. And on the right-hand side, we just have 6 ones. So 1, 2, 3, 4, 5, and 6. So then the next question, of course, is what is each n going to be worth? So we can divide by 6 on both sides, and n is simply equal to 1. So if we were to use a expression to show the same process that we just did with the balanced scale, we'll have 6n plus 6 equals 12. And then the first step that we took was to subtract 6 from both sides. So in the second step, we're left with 6n is equal to 6. Then to solve for n, we divided both sides by 6. So we have simply n equals 1. Okay, so from there, you can look at another example, very similar. But instead of writing out all the individual ones, we can just write numbers. So in this case, we have 13 on the left-hand side of the equation, and then 7 plus 2p on the right. Now, the first step we're going to take is to subtract 7 from both sides. So we will be left with 6 is equal to 2p on the right-hand side. Then we can divide both sides by 2. So that 6 divided by 2 is 3. So p is equal to 3. Okay. So solving these two steps equation then is just those two steps, one after another. Okay, so we're not going to model using algebra tiles here. We're going to simply solve the equations. In this case, the inverse operation of subtracting 2 is to add 2 to both sides. So we can go ahead and do that first. So we can add 2. So the 2's will be eliminated here. So we have 2x on the left-hand side of the equation. On the right-hand side, 4 plus 2 is equal to 6. Then you can divide by 2, which is, of course, the coefficient in front of the x. So then just want to make the colors match here. Just divide by 2, divided by 2. So the coefficients 2 and the dividing by 2 will eliminate each other. And so the final answer is going to be x equals to 3. Now, in this case, notice that the coefficient and the constant that are involved are all divisible by 2. So an alternate way of doing the same question is to start with, we have 2x minus 2 equals 4. And then what we can do is divide both sides of the equation by 2. So 2x divided by 2 is just x, 2 divided by 2 is 1, and then 4 divided by 2 is 2. And then afterwards, we can solve this equation by adding 1 to both sides. You can also get x equals 3. Now, it works really well. This method works really well if you are dividing to get just integers and whole numbers. But if you get fractions, then it's not as good. So whereas this method on the left-hand side is generally what you want to be doing. Okay, let's look at example B. So same thing, right? Notice that if we were to divide everything by 3, it wouldn't be as easy a question. So we will instead add 1 to both sides to eliminate the ones on the right-hand side. 2 plus 1, of course, is 3. So 3 is equal to 3x. Then you can divide both sides by 3, of course. And so you have 1 is equal to x, or x equals 1. Okay, so I'll show you a few more examples here with more negative numbers. And to introduce the idea of checking your answers using this left-hand side, right-hand side grid. So I'm going to go ahead and do the question first. Again, we're going to use inverse operations here. So the first part, we are going to subtract 7 from both sides. So you'll be left with negative 3. X is equal to 19 minus 7 is 12. And then you can divide both sides by the coefficient of negative 3. And you'll get that x in this case is equal to just negative 4. You notice that I didn't cross out the numbers here like I did in previous question. That is more of a visual guide. The steps that you're using the inverse operation are the more important part. So I think it's better if you include those steps. So now that you have an answer, -4, we're going to substitute it back into the equation. So -3 times -4 plus 7. And we want it to be equal to 19, which is the right-hand side. So -3 times -4 is, of course, 12. And 12 plus 7 is 19. So that answer works. Okay. So a couple of more examples here then. Again, we're involving more negative numbers. In this case, we want to subtract 4 from both sides. So you'll be left with 26g is equal to -52. And you can divide both sides by 26. And then, of course, then g will be equal to -2. Next one. So this one's a little bit tricky because people sometimes forget that this negative sign will still be there after subtracting both sides by 14. So we're going to go ahead and subtract both sides by 14. Okay, 24 minus 14, of course, is 10. And on the right-hand side, this negative sign is still there. So you'll be left with -5x. And you can divide both sides by -5 afterwards. And so you'll have -2 is equal to x. Okay. Next one is very similar. Again, we want to use the inverse operation, in this case, of subtracting 10 is to add 10 to both sides. So you'll have 50 is equal to 5x. And then you can divide both sides by 5. And the answer will then be x equals 10 or 10 equals x. And so that's it. Now, quick word problem. Cow sleeps 7 hours a day. This amount of sleep is 1 hour less than twice the amount an elephant sleeps a day. How long does an elephant sleep? So there are a few parts here. First part, cow sleeps 7 hours a day. Second statement is this amount of sleep is, which is our equal sign, 1 hour less than, and then twice the amount an elephant sleeps a day. So to set up this question and to define the variable, the first thing, we can let E be the amount of sleep for an elephant. Okay, so if you look at each part of the statement of the problem, we have 7 hours is equal to twice the amount the elephant sleeps, so twice, so 2. We established that the amount in elephant sleep is E, and then of course it's 1 hour less than that, so we have subtract 1. So we have made an equation, an algebraic equation that matches the statements that was given. So we can now go ahead and solve this equation for E, the amount of sleep for an elephant. So let's go ahead and do that. 7 is equal to 2e minus 1. You can now add 1 to both sides. So 8 is equal to 2e. Follow that up by dividing by 2 on both sides to isolate the variable. And of course, you will get e is equal to 4 hours. Okay. So that's it for this type of two-step equations. Again, you want to isolate the term that contains the variable, and then you want to isolate the variable afterwards. That's it for today. Thank you for listening.